Hi everyone. In this video, I'm going to show you how to find binomial probabilities using Excel. To calculate binomial probabilities in Excel, you want to use the built-in function called binomdist. Binomdist stands for binomial distribution. The binomdist function requires 4 parameters. The first parameter represents the number of successes you're trying to find the probability of. The second number represents the total number of trials, and the third number represents the probability of a success. Now, the last number represents whether or not you're finding a cumulative probability. This is where you designate whether or not you're calculating a PDF or CDF. You'll place a 0 or a 1 in this spot, where a 0 represents the probability not being cumulative and a 1 means it is, where false means no, I'm not calculating a cumulative probability. 0 is for the PDF and 1 is for the CDF. So if you're asked to find the probability that x is equal to an exact number, you'll put a 0 in this last spot. If you're asked to find the probability that x is less than or equal to some number, then the fourth number in your function will be 1. Let's look at an example so we can see how this works. 70% of college students drink alcohol. You randomly select 13 college students and ask if they drink alcohol. Find the probability that the number who say they drink alcohol is, and then there's going to be a few different examples. Is this a binomial situation? First question is, are there a fixed number of trials? Yes, we ask exactly 13 students, so our n is going to be 13. There's only 2 outcomes, a success or a failure. In this case, we're going to consider a success that they do drink alcohol, because that's the thing we're going to be looking for. So the probability of a success would be 70%. And we're going to assume that each one is independent of each other. So when I ask one college student if they drink alcohol, it will not affect the answer of the next. We're just going to assume that's true. So yes, this is a binomial distribution. By the way, I'd like to point out that this is a completely made-up problem. I have no idea what the percentage of college students who drink alcohol is. I just made up these numbers so that I could have an example to show you. Let's look at the first example. We want to find the probability that the number who say they drink alcohol is exactly 10. So we're looking for the probability that x is equal to 10. Due to the fact that we're looking for an equal to or an exactly problem, we're going to be using a PDF here. So that means the last number in our binomdist function is going to be a 0. So we want to do binomdist. Now the first number we want to put in here is our x. That's the value that we are trying to find the probability of. So we want to find the probability that 10 students, so x is 10. So this is the number of successes we're looking for. Then the next number is the total number of trials, which in this case was 13. We asked a total of 13 students. Then the probability of a success, which is 0.7. Remember, in this case, we're considering them saying yes to be the success. And then the last number is, do you want this to be a cumulative probability, binomial probability? No. Okay. So let's see how this would work in Excel. Start by doing equals binom. Now you'll notice that there are 2 binomdist functions. There's the binom dist with the little warning symbol on it, and then there's the other binom dist. The binom dist one with the warning function on it is the one I'm referencing, and you'll see that it gives you this message that says that it's available for compatibility with Excel 2007 and earlier. So this is like the old one, and then this is the new one. I like using this one just because then I know if someone opens it with an older, my Excel worksheet with an older version of Excel, it'll still work. But it really doesn't matter which one you use, because you'll see they say the same thing: returns the individual term binomial distribution probability. They say the same thing, so they will calculate the same thing. I'm going to use that one though. And then you can see it even tells you what parameters it needs to put in, which we already discussed. So the first number is the number of successes we're trying to find the probability of. In this case, we're looking for 10 students to say yes. The total number of trials, the probability of a success, and then do we want it to be cumulative? No. Okay, so the probability that exactly 10 students say they drink alcohol is therefore 0. And let's do 3 significant figures, 218. And if you wanted to, you can convert that to a percentage, but I'm going to just leave it as a decimal. Alright, so to do exactly 13, to find the probability that exactly 13 students say they drink alcohol, we do essentially the same thing. It's the probability that x is equal to 13. Now, in this case, we're going to use the exact same function. It's going to be the binom dist, and I'll write it again, just to kind of be clear, because it's kind of like me showing my work. This time my x is 13, because this is my little x here. Then my number of trials is also 13, my probability of a success is 0.7, and no, I do not want to do a CDF. Okay, so let's go back to Excel and see how this works. So I could type this all out again if I wanted to, but I'm not going to. I'm going to cheat. Well, it's not really cheating. It's reducing the amount of work I have to do. Okay. If I look at this, you can see this is pretty much what I need, except one number is going to be different. So I am going to just use this little cursor here and drag it down, and that will copy the exact same thing. Okay? But what I want to do is change the first number to a 13. All right. So the probability of exactly 13 students saying they drink alcohol is 0. And we're doing 3 significant digits here, so these 2 zeros don't count. And I'm going to do 969. The examples we've looked at so far have asked for the probability of an exact amount of successes. What if we want to look for a range of successes? Something like the probability that at least 11 students say they drink alcohol. First, let's look at how we would write that. That would be P of x at least means greater than or equal to 11. To calculate this, we're going to have to use a probability rule. The probability that x is greater than or equal to 11 is the same thing as the probability that x is equal to 11 plus the probability that x is equal to 12 plus the probability that x is equal to 13. So why? Why are those two things equal to each other? Remember, this is a binomial distribution with a total of 13 trials. So for it to be greater than or equal to 11, it would have to be equal to 11, or 12, or 13. Now, I was emphasizing the word or when I said that. The reason I was emphasizing the word or is because in probability, you represent an or with a plus. Why is it an or and not an and? If I were to perform this experiment, and you asked me, how many students said they drink alcohol? I can't tell you 11 and 12 and 13. That doesn't make any sense. I can't have all three of those answers. I can either have 11 or 12 or 13. So that is why it's an or and not an and. Anyways, if I want to do this in Excel, I just need to do the binom dist function for each of the three and add them up. So let's go back to Excel. Now if I look at my previous one, this actually has one of the ones that I want to do in it. I'm going to copy it to the next cell, and then I'm going to copy and paste this within that line. So Control C, and then plus, paste, and I just need to change this to an 11 and that to a 12. Okay. The probability that at least 11 students say they drink alcohol is 0.202. All of the examples we've done so far have been examples of using the PDF distribution. Let's try some that use the CDF. So remember, the CDF is a range. It's not just one value. And the important thing about it is that it needs to be written as an x less than or equal to some x. Now the problem with that is that most of the examples that we're going to see, they will not be worded as x less than or equal to some x. So we will have to translate them so that they look like this. For example, if we want to find the probability that less than 4 students say they drink alcohol, that would be the probability that x is less than 4. Well, we need this to be written with a less than or equal to symbol, not a less than symbol. Sometimes it helps to draw a diagram of what this represents. Remember, we're looking at a discrete probability distribution with 13 trials. Okay, so I could draw my little line, and I can do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's 13, here's 0, and all of my options are within here. X less than 4 would look like this, so it would not include 4, but it would include 1, 2, and 3. 2 and 3. This is x less than 4. Oop, forgot the 0. Therefore, this can be rewritten as the probability of x less than or equal to 3. So to calculate this, all we need to do is the binom dist. The first number is our little x, so in this case it's 3, not 4, it's 3. That's why we went through this whole thing of rewriting it. Our number of trials, our probability of a success, and this time, yes, we do want it to be cumulative. Let's view this in Excel. I'm going to copy this one, paste it here, and I want to change this 13 to a 3, and change the 0 to a 1. The probability that less than 4 students say yes, they drink alcohol is 0.1230652. All right. The probability that x is at least 4, that represents 4 and greater, so x is greater than or equal to 4. Whenever we use the binom dist function, we need this arrow, or this inequality, to be pointing to the left. It needs to be a less than. We can rewrite it as a less than by using the complement rule. Let's figure out what the complement of this would be. If it helps, drawing a number line, you can. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. X greater than or equal to 4 be 0, 1, 2, 3, 4 would be all of these. Okay. So the complement of that would be these over here. And that represents, so this is 0, 1, 2, 3, so x less than or equal to 3. Remember, when you use the complement rule, you do 1 minus the probability of x less than or equal to 3. Well, we already found the probability of x less than or equal to 3 in the previous example, so I can just do 1 minus 0.000652. So I could calculate that by hand if I wanted to, or if I wanted to do it in Excel, I could come up here and I can do equals 1 minus, and then just click on the previous cell. So it equals 0.999. And for at most 4, that means the probability of x is less than or equal to 4. Now that's nice because that's already written in the format we need. We can just come over here to Excel, and I'm going to copy this one and put it there. And I'm just going to change that 3 to a 4. Oopsie. I'm going to change it to a 4, not actually delete it. So the probability that at most 4 students said they drink alcohol is 0.00403. And the last one, the probability that more than 4 students say they drink alcohol. So that's the probability that x is greater than 4. We'll need to do a complement rule again because our inequality is going in the wrong direction. Here's our 4. So if x is greater than 4, it starts at 5. Therefore, the complement would be this over here, which is x less than 4. 1 minus the probability that x is, less than or equal to 4. Okay, and we found that in the previous example. So I could just do the 1 minus this cell again, but this time I want to actually type it all out so we can see how it works. So that equals 1 minus binom dist 4, 13 trials, 0.7 probability, and yes, I do want it to be cumulative. 0.996. And that's it. The big thing to remember is if you are doing a single value, you want to put a 0 in that last slot. If you're doing some range of values, you want to put a 1 in that last slot. And you always want to make sure your probability is written as a less than or equal to.